Okay, I'm not necessarily sure why I get myself into certain fixes, but I've been wanting to do this for a long time, and I figure there is no better time than the present because we're going to be making a god awful amount of steam. So we might as well use all of the potential steam energy that we can use and the excess hydrogen that comes out of it. So we got that covered with the engine and water heater and all that stuff down that line. We've got direct electricity to from hot steam or hot directly to electricity. We got that covered. That's not a problem. I'm going to give you three guesses what's behind this cardboard. Okay? Yes, you're absolutely correct. It's a Tesla turbine. Okay? Yeah. This is my Tesla turbine so far. Okay? I have all my discs bolted together. Dr. Divine has no idea. I told him that those discs are going to get repurposed. These are computer disk drives and tape reels, but they're going to work perfect for the boundary layer effect. And you see how they overlap? I have them perfectly overlapped. So they're going to give the correct amount of exhaust, and it's tunable. I can make a full exhaust, or I can make each one force each one to its port. That is one of the issues with the Tesla turbine is tuning the exhaust. Okay, I got the intake plenum completely understood because Tesla knows very much about what's called power balance looping. Okay, power balance looping is a very understandable. You're looking at it. Okay, this is power balance looping and this is power balance looping. And if you look at Tesla's patents, he clearly knows what power balance looping is. And gas, steam, just gas, steam, fluid, electricity, and even sound all work in the same principles. Okay? So, something I added though that I thought was pretty trick. You see these little eccentrics here? Well, we have a bag of them over here on the shelf. Okay? And they've been here for maybe, I don't know, like 50 years. And we can't figure out what to do with them. So I've been finding all kinds of neat things to do with them. If you looked at my TIG torch, they're on my TIG torch as clamps for the electrical. But they're little eccentrics. Okay? See that? And so now I got this side done. And now I'm just about, I got myself into a stop for a moment because I started thinking about the exhaust housings and how they're going to work. But these are going to go on this side too as static balancers. They'll automatically balance the load and keep the vibration down as this thing spins. So I thought that was a pretty trick little addition, because in a turbine of steam, one of the issues is harmonic vibration from the steam, because it's steam. It's a fluid and it's a gas at the same time, and it's always going through a transition. Then the other trick thing is I don't remember the name of the oxide for recording tape. I'm sorry, but they hold the magnetic moment. Okay, and so if the Tesla turbine is a boundary layer turbine, then you want the lens effect and the magnetic moment to grab this disc. and it's very smooth. These ports are designed, well, they're on the recording, they're getting used whether I like it or not, but they have a phenomenon because as the gas comes across here, it's going to have a pocket to grab as it expands, and that pocket is going to be like torque, but it's not a ripple vein that it has to overcome. It's a pocket of torque, and as the gas expands, it's going to create a vacuum and pull more gas in, but then the centrifugal force is going to pull it back out. And this shape might be something extremely interesting. But then as it comes into this port here, it has to, if it spins this way, okay? As it spins this way and the gas comes in here, it's going to hit another vacuum and expand here, and that's going to do a cooling effect before it exits. But that vacuum is going to keep the gas in there to give even more torque. And the exhaust is going to be here, not here, I think, right at the moment. It's going to be here along this line right here. So this whole thing is going to be the exhaust port around here. So far, that's what I think so far. Then I came up with this. It's just a fan blade. It's nothing special, okay? If I put this like this, then I can have a turbofan effect, okay? Just pretend you're looking from the inside of the rotor. I can have a turbofan effect on one side. And even though Tesla's dumps on both sides, I don't think that I want it to dump on both sides. There's a reason for that, because he knows about power balance looping. So if I use a smaller one on the other side of this, the smaller one, it will act like a turbocharger. As the gas, if you look at his patents, he knows about gas expansion. One side of the turbine coming in, the input gas, is coming in under high pressure. But then it comes around and it comes out under low pressure. So he's drawing through and then he bridges it. That bridge is technically a power balance loop, and he has valves on either side to balance the power balance loop, okay? Then he bridged the power balance loop again into something that I call a series parallel capacitive circuit, but it's an extension to a power balance loop. And as he comes out to the next loop, he has another set of valves, and he has a petcock to balance that load. As the gas expands, it needs a place to balance itself out eventually, and then he tied it into the intake again, giving a third power balance loop under pressure. So if that works on the intake, well, then it should ultimately turbocharge the exhaust. And this and this are just maybes. It's not necessary, because I'm going to be pulling a vacuum anyway on the exhaust. So those can go over there, and I can just go back to simplified exhaust. And this will be the tubing that fits the exhaust. And I'll slice it and hold it down so that I can put bearings. And I have a couple pieces of steel or a couple pieces of aluminum to hold the bearings in the shaft. It depends on how I feel. It doesn't really matter because it's going to get bolted together anyway. I'm not going to weld it, so I can take it apart and examine it. But that's kind of where I'm at. But he definitely has the exhaust in the power balance loop as well, because if you look at the exhaust that comes together on the side of the turbine, when the turbine is sitting like this, okay, when the turbine is sitting like this, he has the exhaust right in the center, but then he has another power balance loop with a just a regular petcock like this, so that he can control the balance between the two sides, and that's it. So he completely understood power balance looping. But I'm going to do one more thing. The center discs here, they're just going to float. The outer discs and the center disc, they're solid set, and they're pretty good. But I'm going to let the center ones just float, because centrifugal force will put them in the center. But as the fluid needs to go through its standard motion of a standing wave, the disc will float in that standing wave. That's my take on it. See that? And centrifugal force, they'll just go right in the middle. They will not fly out here. They'll stay in the middle. And in the worst case scenario, that's a very simple fix by just putting a little something like that. And that will keep them exactly. But I don't want them to be bound. I want them to float. I want them to float back and forth, because they're going to do something. They're going to grab the disc. I may put the screw here. Either way I do it, the disc is still going to float, because I want it to go through that standing wave motion in a longitudinal fashion. It will just naturally do that. Okay. Housing time. Here's your update. You know, sometimes I don't need to do this stuff, but I'm doing it because I can. And I might as well. Like I said, I might as well, because it is definitely the most efficient turbine available. Who cares? Who cares how fast it spins? I don't care. If it spins fast enough to turn this, you saw it in the last video, this electric motor generator, then that's perfectly fine, because this is rated at 30 volts DC and 1 amp. The linear circuit takes literally no amps. I can overdrive this thing without it hurting it, and I could loop this power back into the circuit. Like I don't really need any more, because I already am 100 to 500 watts in and 73 or 168 amps out, and of effective heat power, and 44,000 watts squared, depending on resistance between the dry and the wet. So I don't necessarily even need to do this, but I'm doing it just to raise the bar. I don't know. Not every power plant will utilize all of these different components. Maybe a power plant just wants to go from fusion, steam, directly to wet steam and turn a turbine. Maybe they want the full package. I don't know. This is a demonstration unit so that we can check every different parameter individually and figure out which one suits which customer. And I say that not very lightly. I have customers lining up right now. So I'm okay with customers. That's not the issue. The issue is making sure that they clearly understand the simplicity of the system. Even though it may look a little complicated to you at the moment, I'm trying to make it as easy for you to understand as possible. So this, like I showed in the last video, is where I am at with a power balance loop. Okay? Exhaust, expansion chamber. Now, this expansion chamber is a principle of vortex expansion in vacuum. This principle is well understood, okay? It's well understood by me. It's well understood by a lot of people. And if you really want to have the understanding of it, go buy a Dyson vacuum or go look at a Dyson vacuum. He has a parade of these because he clearly understands this principle. Okay? Then the bubbles that are in the expansion version will be drawn down under a vacuum again and power balance loop through the system. This will be the extremely high vacuum here, okay? We already pulled 40.8 inches of vacuum because this jet and this jet, I own the patent on the ratio of these from 1998, okay? It is now relatively expired, but there's a ratio that took me a box. I am telling you, I had a box at least that big of fittings, brass fittings, to try to figure out that golden ratio. And it's just a secret, okay? The patent, you can look it up. I don't remember the number. I used to remember it off the hand. It's a design patent, and it's under BDM Engineering. So it's not under my name. It's under BDM Engineering, my engineering company that I owned. So this particular ratio is also what's inside of here. That's why the light ball can lift the heavy ball. Okay, that's technically contrary to Einstein's mass. Okay, but it gets better the heavier and the denser the fluid that you lift. The light fluid will definitely pull the heavy fluid even harder. So once fluid starts going through this, just expect that ball to always be pegged, because it's just for my low flow ratio. Once I have the low flow ratio and I can turn up the gross valve, I'm not worried. It's just so I can look at the arc under a specific ratio. After that, I don't care. It's not important. Okay? Because you can't, the valve would go, basically, I would have to have a tube that's maybe 5 foot tall to deal with this flow that's going to come out of this. So it's really not important. Okay? Let's see what else. Oh yeah. On the top of the reactor, once everything is set, we'll just have a pressure regulator, because we only need to deal with 10 psi. I'm not going to go any more pressure than that, because if I can't do what I'm expecting or what I'm going to figure out at 10 psi, then there's no point of going any high pressure. Okay, because 10 psi, because this is a sealed system, it's technically 24.7 psi starting, okay, at atmosphere, because this is a closed atmosphere. And then every atmosphere, every pound here should be equal to every atmosphere. Even though the gauge says 5 pounds, it should be equal to every atmosphere because I'm pulling a vacuum back through the closed loop system, and the contraction of the water will be just like the rain cycle when you have condensation and contraction. So that contraction with the Tesla turbine has a phenomenon that goes from steam to liquid, which is a great phenomenon because then that liquid is technically useless. Okay, it has no steam value whatsoever, so it cannot ever turn another turbine. So that's the main problem with a turbine steam power plant, is they have to figure out how to go from saturated steam to liquid water again so that they can reheat it again. It's a ridiculous process. That's where Stream Me comes in, because it can take that water from 180 degrees of cold right below boiling point and go all the way down to almost room temperature, 4 degrees above room temperature, and still make electricity. But if I gradient, like on a cold day, if you're in Russia or if you're in Canada or someplace cold, okay, Northern California, foothills, Tahoe, I'm just kind of globalizing it. I'm not actually picking a specific country that I want to deal with. This Stream Me, the gradient between ambient and that even gets better. And that's the main problem right there with all steam generation, is they do not know what to do with the 180 degree water, but they got to get it colder so that they can go back and give it more energy for steam. Because even at 180 degrees, they don't have the empathy that they need to get the steam energy. There's a phenomenon between 180 and 212, and they have to be below that. But once they're below that for them, it costs them a tremendous amount of energy to chill that water. So they use large chillers and vacuum pumps in the AC cycle. Stream Me completely eliminates that. And I'll give you a ratio of this 20-acre power plant. At least 10 acres of this 20-acre power plant was related to that subject alone. And that energy just went in the atmosphere. Minimum 50% of their energy went into the atmosphere. As the steam turbine comes out of the steam turbine, the gas is 1,050 degrees or something. Okay, then it goes through the evacuation process through the vacuum pumps of an AC cycle, and it drops down to 600 degree water. At 600 degree water, which is a tremendous amount of potential for me, then from that point, it has to go into the chillers, and that 600 degrees water has to be brought down to a minimum of 90 degrees, okay? A minimum. And then it has to be as close as they can get to ambient temperature to start over again. So now you have a tremendous amount, over 50% sometimes, of heat loss. And a power plant of a steam generation at their best day is 60% efficient. So at the worst day, that's 40% of all of their energy going down the toilet. If you add that to the fact that we can turn down the generator a fourth, that puts a power plant of my design that I will own nobody can compete. Okay, there is no competition for that architectural design. So there we have it. Okay, so since I'm on this subject of Stream Me energy, let me show you what I'm talking about. Okay, we're going to take a little walk. Okay. Here. This is my basic whiteboard. There's a video, but I'll just go over it again so that you understand. This is a 40-foot shipping container, 4-phase superconductive grid system, okay? This is out to the lovely, wet, hot, steamy fusion reactor. If you notice, there's no dry reactor because this customer does not need dry, okay, at the moment. This is why. This is the beauty of this system, okay, in this patent disclosure. Remember, I have time on my side right now with this patent disclosure. So I want to make sure that the patent officer who reviews the online information that he's going to see understands that the date today on this patent disclosure is February 14th, 2020. Okay, so I have a year under this patent disclosure. This is the hot, wet, steamy, lovely reactor. Hot steam goes into his pulp tank. They're removing the laxathin and doing a bioplastic, but it's not plastic, it's fiber. So it's fully degradable. And when they told me, now this customer and I, we have a lot of money under the bridge already in customer cons, so they're a very good customer. I'm not even worried about that, okay? But when they told me that they're doing plastic clamshells for fiberware and silverware and hamburger clamshells and so forth and so on, and restaurant straws and anything that they can conjure up, I said, I'm all in. I am definitely all in, and I'm pulling out all the stops for you, okay? So now their pulp tank, they'll have a screw press with a lid on it so they can do a massive amount of flow through. The hotter the steam, the more flow through, okay? That's their number one problem, is getting the steam from a regular natural gas boiler. So after the pulp comes out, it's going to be technically cold steam. It's going into their boiler. Their boiler exhaust here is going to be implanted in a power balance loop, MOSI injected into the superheated steam, okay? Then it's going to come back in here to the catalyst, GC36 HD 54 074 AU 197 M11 number 26. It's a CO2 explosive catalyst where I can take and explode CO2. Okay? I can explode it and implode it. Anything that's left in here will go down to its base ground state. That's how powerful the catalyst is, and it'll just bring it to heavy hydrogen. Okay? Then the hydrogen fuel, hydrogen deuteride, will be filtered, come through here, and fire the boiler in a complete closed loop. Okay? There is no outside oxygen needed in this process. This is proven technology time and time again by me. Okay? Then the hot water, it'll get another power balance loop from the boiler here and go through direct heat to electricity through the steam meet process, which brings amps. Even though I don't need any, it brings linear amps to the circuit, which then makes this a extremely hot steam. Okay? Extremely hot steam. I showed you yesterday about the balancing of the electric motor just so you could understand that frequency has power. That will bring linear amps into this and make this extremely hot, okay? The more pressure, the hotter it gets, just like boiling a pot, but there's a gradient that's linear and it's ridiculous, okay? I only need a couple PSI of pressure and this becomes extremely hot. The catalyst alone, when it's been decanted, the top water, you can put it on an open flame, an open burner, and it will not boil until 530 degrees. That is IP protected. Fluid number 26. Then, as the amps bounce back through the linear circuit, the trickle from the grid. Now, I want to say something one more time. There is no such thing as free energy. That is a myth. There is no fusion reactor in the planet that will automatically self-loop because you cannot overcome gravity. Okay? You can never have free energy on this planet. Maybe away from a gravitational pull, that story's different, but on this planet, you'll never, ever loop a donut toroid fusion reactor and have it self-run. It may run for a couple of minutes at the most, but gravity will destroy it because ultimately, plasma is a neutral gas. I've just been able to move plasma as a motive force. The circuit definitely produces superconductive electrons and moves, but I've only let the plasma and the reaction run, and I have a video that I'm going to unlock shortly, and it ran for about 30 hours all by itself. And then quit. I know exactly why it quit, but it does not relate to gravity, okay? Just leave that be. This will be perfect power out, perfect phase angle power to run their thermal motive light loads, and you are welcome. Because the reason we're doing this is to protect our photosynthesis cycle that electromagnetism is currently defeating. Okay? There is your update for today. And that was your privileged tour.